Hi folks, today we're going to concentrate on scientific notation and things that we can do with scientific notation dealing with exponents. So right now, where I really want to start out is just reminding you what scientific notation looks like, where you have a number times 10 to some power, all right? Now, yesterday you learned how to deal with negative exponents, and your answers should not have negative exponents in them. The scientific notation is the only place your answers should have negative exponents. Now, scientific notation, this number that's out in front needs to be a single digit number from 1 through 9 on the left side of that decimal point. So right now we have 8.3 times 10 to the 6th power. This is in scientific notation. What I'd like to do is transform it into standard notation. So if you notice, we have the 8.3 times 10 to the positive 6th. So positive exponent means that we're going to have a bigger number. Now that bigger number, all it means is we're going to take that 8.3 and we're going to move our decimal place 10 or 6 spots to the right. So 1, 2, 3, 4, 5, 6. Now, for every empty spot that we have there, we can just fill that with a 0. So our number, if we put the commas in the right spots, our number, 8.3 times 10 to the 6th, is actually 8,300,000. So scientific notation does have its advantages, is it allows us to write very, very large numbers in a more compact form. It does have its disadvantages too, where you can have a regular number, maybe like 800 in standard notation, or it would be 8 times 10 to the 2nd in scientific notation, and it just doesn't make sense to write that number in scientific notation. The next example, 7.2 times 10 to the negative 3rd. Now notice our exponent is negative this time, which means we have a very, very small number, which means that our decimal point is going to move 3 spots to the left. So 1, 2, 3. And then every one of those spots we would still fill with a 0. So what our number here is, 7.2 times 10 to the negative 3rd, is actually 0.0072. Now, as I stated, this is probably nothing new for you, but it sets us up for what we're about to do next. The first example I'm going to show you here is 2.6 times 10 to the 5th times 3.7 times 10 to the 4th. Now, there's a couple different ways you can do this. Probably the quick and easy way would just be to plug this into your calculator and get the scientific notation answer back out. But there is another way that you can do it, where you start off by just multiplying those two numbers right there, the 2.6 and the 3.7. When you multiply those two, you get approximately 9.62. Now we can turn our attention to some of the things we learned from yesterday, where we have this 10 to the 5th and 10 to the 4th. They're the same base numbers and they're being multiplied, so we could just go ahead and add those exponents. So it'd be times 10 to the 5 plus 4, or 9. And that would be the final answer. Whether you put it into your calculator or did it like that, either way, that's it. Same type of thing over here. You would have the numbers out front, 8.6 and 4.1. You could go ahead and multiply those two together. You'd get 35.26. And then treat the exponents, the powers of 10 the same way. So you'd have 10 to the negative 5th, 10 to the negative 9th. So you'd have times 10 to the, now we can add those exponents. Negative 5 plus negative 9 would be negative 14. Now there's one problem with this, is it's not truly in scientific notation because we have a 35 in front of our decimal. This needs to be a single digit number between 1 and 9. So what we're going to need to do is we're going to need to move that decimal point over one spot. So we have 3.526. And when we do that, this is going to change. Our exponent's going to change in that. So now it becomes 3.526 times 10 to the negative 13. And there is our final answer. Here's a couple more examples. This time we have division, and really we don't treat anything any differently. I know this is kind of hard to read. This is times 10 to the negative third, and this is times 10 to the seventh. You can see it a little bit better on your sheets. But we start out just dividing. 6.4 divided by 2.1. So we will get approximately 3.05. And this time, with our powers of 10, since we have the same base numbers on top and bottom, we can subtract exponents, top minus bottom. So it'll be times 10 to the negative 3 minus 7. So negative 10th power. And we can leave it like that because scientific notation, it's okay to have a negative exponent, and the number on the left-hand side of the decimal is a single-digit number between 1 and 9. So we're good. This last one, 2.4 times 10 to the 6th, raised to the 4th. So really what winds up happening here is this 4th power comes to the 2.1, and it comes here. So 2.1 to the 4th is 19.54. Or I'm sorry, 19.45 times 10 to the, now we can multiply those exponents. 6 times 4 would be 24. And again, we have an issue because the number on the left side of the decimal sign is 2 digits. We need it to be 1. So we have to move that decimal point. So it'll be 1.945. And since we moved the decimal, that needs to change, so it'll be times 10 to the 25th. And there is the final answer. Again, these are things you can just plug into your calculator and get done, or I think doing some of these with the shortcuts can be fairly simple as well, as long as you get the hang of it. So need to practice that. So your practice is on page 333, numbers 15 through 23, and 49 to 50. We'll see you tomorrow.